Okay, so hello guys. So I wanted to go over this video, and this is over rational inequalities. So I'm probably gonna do 3 examples. Well, I'm gonna do one example in this video, and then in the next 2 videos I'll do other examples. So basically a total of 3 examples in 3 videos. So with these, I did actually I did kind of struggle with figuring out how to do these. So I'm going to do my best to explain how to do this problem. And this is a pretty easy example, so it's not as difficult as the next 2 that I'm going to go over in the next 2 videos. So yeah, so in this example, it says solve the rational inequality, and this is the rational inequality that we have. X minus 1 over x minus 3 is less than or equal to 0. So the first thing that I want to kind of emphasize here is, so let me just kind of write it down. X minus 1 over x minus 3. 1 second, guys. 1 second. Okay. And also, I do apologize. I'm still kind of recovering from a cold, so if my voice sounds a little deeper, I do apologize. So this is x minus 1 over x minus 3, and then it's less than or equal to 0, right? So the first thing that I want to do is I actually want to list my restrictions here. Obviously, if I look at my denominator, we know that we can't have a denominator of 0, so what I'm gonna say here is that x minus 3 cannot be equal to 0, right? So here, I'm gonna just solve for x, and I'm gonna say that x cannot be equal to 3, right? So that's one of my restrictions here. And then, let me see, so, okay, so then another thing is, since 1 can be equal to 0, if we solve this for x, we know that 1 can be equal to 0, so we know that 1 can be a solution to this, or it's going to be included in the interval. So we know that x minus 1 can be equal to 0, so if we add 1 to both sides, we know that x equals 1 is going to be included in the interval, right? That's if you solve the equation x minus 1 over x minus 3 equals 0. You're just basically multiplying x minus 3 on both sides, and then solving for x. You cancel this out. X minus 1 equals 0, and then add 1, and then get x equals 1. So we know that x equals 1 will be included in the interval, and also x equals 3 will not be included in the interval. Now, between those two, what I'm basically going to do here is I'm going to draw a number line. So let's see here. So we're just going to kind of draw a number line here. Let me go ahead and do that. Okay, so basically following kind of the rules here, I know that 1 can be included in the interval, because if I plug 1 in, I'm just kind of letting you guys know, if x were to be equal to 1, I can say that 1 minus 1 over 1 minus 3 is less than or equal to 0. And this is true because if I have 0 over negative 2 less than or equal to 0, this is really 0 is less than or equal to 0. And this is true, right? So I can include 1 in the interval. So I know for sure that 1 can be included in the interval. Now, as for 3, like I said, it's in the denominator, so we can't include that, right? Now, the idea here is that, basically what we're doing here, we're going to go ahead and look at all the numbers that are less than 1. So basically from the interval negative infinity to 1, including 1, which is basically this part over here. And then the interval from 1 to 3, so the interval from 1 to 3, which is kind of this part here. So it's bracket 1 to 3, parentheses. And then the interval from 3 to infinity, which is, so this is 1 to 3. And then the interval from 3 to infinity, which is this. And we're not including 3, because 3 is in the denominator, right? So we're going to say parentheses 3 to infinity. Now, these are not the answers. We're not done yet. We need to test them out. These are our test intervals. So I'm going to make a chart, and I'm going to put interval, and I'm going to start with negative infinity to 1. We know that 1 is included, so we don't need to use 1 as an option for this. We can include something between that. So we can use, for example, so we're going to put test x value, and we're going to put x is equal to 0. So when I do that, if I say x is equal to 0, I'm going to test 0 as my value. So I'm going to say, so we know that the inequality is x minus 1 over x minus 3 less than or equal to 0. So x minus 3 less than or equal to 0. So we're gonna test x equals 1. Or I'm sorry, test x equals 0, excuse me. So when we do that, we have 0 minus 1 over 0 minus 3 less than or equal to 0. This gives me negative 1 over negative 3 less than or equal to 0. These two cancel out, and then we have 1/3 less than or equal to 0. You're not switching the inequality because there is nothing that's being multiplied by a negative in the right side. If there was something being multiplied by a negative on the right side as well, or divided by a negative on the right side, then you would have to switch the inequality, but we're not doing that. There's only something divided. There's a negative over a negative here, and not on the right side, so we don't need to switch the inequality. I just want to make that very clear. Do not switch the inequality, because that's going to mess up your answer. So we have 1/3 is less than or equal to 0, and that is not true. That is not true, right? So we know for sure that negative infinity to 1 is not, we end up with 1/3 less than or equal to 0, which is not true. So no, this does not work. So this is not going to work. Now, the next one we're going to do is from 1 to 3. Now again, we know that 1 is included in the interval because, like I said, it's a solution to it. When we solved this for x, when it was equal to 0, we got x equals 1. So again, it is included in the interval. So we're going to pick a number between 1 and 3. So this time I'm going to do x equals 2. So if I do that, again, I'm going to have x minus 1 over x minus 3 is less than or equal to 0. This is, so we're going to do, again, x equals to 2. So we have 2 minus 1 over 2 minus 3 less than or equal to 0. This is 1 over negative 1 less than or equal to 0, which is negative 1 less than or equal to 0. This is true. So we know for sure that negative 1 is less than or equal to 0, so yes, this works, right? So we know that another solution to this would be from 1 to 3, right? Oops, I did not mean to do that. So this works. Now what about 3 to infinity, right? So now we're going to do from 3 to infinity. So, and of course, 3 is not included in the interval because it's in the denominator, right? We don't want a denominator of 0 because that's going to be undefined. So this is going to be, so we're going to, again, we're going to test an x value from 3 to infinity. Let's do x equals 4, right? So if I do x equals 4, I'm going to have x minus 1. So again, I'm going to just rewrite my inequality, x minus 1 over x minus 3 is less than or equal to 0. And again, I'm going to go ahead and do x is equal to 4, right? So I'm going to do, when x equals 4, I have 4 minus 1 over 4 minus 3 is less than or equal to 0. This is 3 over 1 is less than or equal to 0. And I end up with 3 less than or equal to 0. This is not true. 3 is greater than or equal to 0. It's not less than or equal to 0, so that does not work. So I know for sure that I end up with 3 less than or equal to 0, which is not true. So no, this does not work. So this inequality will not work. So what's my solution? Well, my solution will end up being the interval from 1 to 3, where 1 is included in the interval. So this is my solution to this inequality. Okay, so that is how you do this problem, guys. I know it's a lot of explanation. In the next 2 videos, I'm gonna do some tougher examples, and it's probably gonna be longer. But please bear with me. These are very, very, very hard. You have to be careful with these. So, and that is why I want to explain it very well in case there are any questions that do arise. I want to be very clear as to what I'm doing when I'm doing these problems. So I know it's a very long, I know I can take very long, but I just want to clear up any questions that there might be. So thank you so much for watching, guys. And that is it for this video. And please like, comment, and or subscribe. And thank you so much for watching. And I will see you guys in the next video. Bye, guys.